Alright, so any other questions? Sweet. Today then, we're talking about function composition, which is basically taking one function and putting it into another. So applying one function to the results of another. A lot of times it'll look like these two different things written here. Right? G of f of x means the same as g of f of x. Right? These two mean the same exact thing. Now, I prefer it written this way, and it'll be written that way most of the time, but we will see problems written like g of f of x. We'll see it actually pretty frequently on our homework. If it is written like this, you'll see me rewrite it. I'll rewrite it in this form, because that's the way that it works in my brain. If you like it better the first way, that's fine as well. You'll notice this dot here is not actually a dot. It's a circle. Right? There's a white space in the middle there. It is not a multiplication sign. That means the composition of those two functions. Now what we're doing is we're taking the result of f and we're sending it through our g function. Alright, we say it g of f of x. So you take your result from your f function, you send it through your g function. We were working inside out. Always starting in the middle, working our way out. Alright? JJ, which way are we working?
Middle on the way out.
Middle out, inside out, right? Start in the middle, work your way out. So, if we're given two functions, f of x and g of x, and we're asked to evaluate a composition of functions like g of f of x, and we're asked to do that, what we're going to do, take the result of f of x. Well, take what f of x equals, which in this case is 2x plus 3, right? Replace it. Make it g of 2x plus 3. Because what we're going to do is we're going to take that result, that 2x plus 3, and we're going to send it through our g function. So we're going to take it and we're going to plug it into our g function anywhere we see an x. So I'm taking this number, 2x plus 3, and plugging it in anywhere I see an x in my g function. So it becomes 2x plus 3 squared. Right, we're taking that result that we found from f of x, plugging it into our g function. And then, do you think we should leave an answer like that? Probably not. 2x plus 3 times 2x plus 3, and FOIL it, right? Squared means times itself. So, 4x plus 12x plus 9. 4x squared, excuse me. And that's my answer for g of f of x. We took f of x, we plugged it into our g function. Okay? Does that make sense? Now it asks for the domain. Domain, we learned it yesterday. Looking for radicals, looking for denominators, not only in where we finish, but where we began in g or f of x. Do I have radicals or denominators in any of those pieces? No. So my domain, I have no restriction. It's going to be x is in the real number set, and it's going to be negative infinity to positive infinity. Okay? Any questions? Alright, let's try going the other way. F of g of x. So we want the result of g of x, or what does g of x equal? In this case it's x squared. So I'm going to rewrite it as f of x squared. And what I'm going to do is I'm going to take that result, that x squared, and I'm going to plug it in to my f of x function. I'm going to plug it in anywhere I see an x over here. In this case it's being multiplied by 2. So I'm taking 2 times x squared plus 3. Does that make sense? Yes? No? Okay. So I'm going to do 2x squared plus 3. I do that multiplication. And that's my answer for f of g of x. Now, Simon, what do you think my domain is going to be for that problem? Am I going to have any restrictions?
No.
No, right? I don't have a denominator. I don't have any radicals. X is the real number set. Negative infinity to positive infinity. Any questions? All right. Turn it over. Let's keep moving. So, start on the inside, work your way out, right? We talked about that. What are the domains? Well, we can probably do all three of these at the same time, can't we? Right? Do I have any denominators throughout those three functions? No. Do I have any radicals? No. So am I going to have any restrictions for any of these three functions? No. So x is in the real number set, negative infinity to positive infinity. I'm just going to go for all three of them. Right? I'm going to save some time. I'm not going to write them all out. Okay. Find f of g of x and the domain. So the result of g of x, right? What does it equal? It equals x minus 4. F of x minus 4. So I'm taking x minus 4 and I'm throwing it into my f function. And I'm plugging it in. Anywhere I see an x in my f function. In this case, I have one right there and I have one right there. I'm replacing those x's with x minus 4. So I get, instead of x squared, now it's x minus 4 squared. Minus 5 times, instead of x, now it's x minus 4. Plus 3. Do we all follow that? Do we all see why we're taking x minus 4 and we're plugging it in to our f function here? You all got that? Okay. So now all I have to do is algebra. I'm going to FOIL out that first piece. I'm going to distribute my negative 5. I'm going to combine my like terms. Right? X minus 4 times x minus 4 minus 5x plus 20 plus 3. So I get x squared minus 8x plus 16 minus 5x plus 23. Right? FOIL out this first part. Combine my like terms over here. X squared minus 13x plus 39. So that's my answer. That's what I got. Now I need to find my domain. Sardina,
Yes.
do I have any denominators in my end result?
No.
Any radicals in my end result?
No.
Do I have any restrictions in there? In the end result?
Oh, no.
Do I have any restrictions for my original two functions?
No.
So, I'm good, right? This x is in the real number set. Negative infinity, positive infinity. Does that make sense? Any questions? JJ?
Wait, I thought you said we didn't have to use the real number set on the test.
We will not use real number notation on the test, but it's still good to practice it because it does show up on like the ACT and other standardized tests and things like that. So that's why we show you both of them, but we require you to, geez, tough words, require you to use interval notation because you'll see it next year in pre-calc and probably in calc the year after. Okay? Alright, h of f of x. So, f of x. Right? Replace f of x with what it equals or what its result was. X squared minus 5x plus 3. Well, take that result and throw it into the h function everywhere you see an x. Well, in this case it's just times 5. So, 5 times x squared minus 5x plus 3. At the end I still have plus 1. Right? So instead of 5 times x, now it's 5 times f of x, or x squared minus 5x plus 3 and then plus 1. What do you think I should do next?
Distribute the 5.
Distribute the 5. So distribute 5, we get 5x squared minus 25x plus 15 plus 1. Then just combine your like terms. 5x squared minus 25x plus 16. Okay. Hey Ben, do I have any sort of restriction from this end result?
No.
Do I have any sort of restriction from my original functions?
No.
So, I'm clear, right?
Mm-hmm.
Sweet. X in the real number set. Negative infinity, positive infinity. Question?
Yeah, so I thought we put like h of x in for wherever the x is into f of x.
No, remember we're working inside out, Ty. So we're starting with f of x, and because I have what f of x equals here, I'm plugging it into my h function. Okay, so whatever's inside this parenthesis is what I'm plugging in for x. Does that make sense?
Yeah.
Just like if it was like h of 3, you would plug 3 in for x, right? We've done that before.
Yeah.
Yeah, so same thing, except now we have this big old thing in there. Then we'll plug it in. Do you have a question, Braden? Okay. Alright. Let's keep going. I'm going to give you guys about a minute. I want you to find the domain for those 5 things. Take about a minute, minute and a half, find the domain for those 5. Right at the top. I'm pretty hungry. How's it going?
Good, actually.
No, this one you listed greater than or
Where's the
Not like getting a head start.
So we're getting x squared.
Yeah.
Almost.
I'm gonna erase all of it just for you.
Well, you did actually extra.
Yeah. Where's the top 5 at?
What?
X equals.
Yeah, can you just leave it at this?
-2.
How do we, what is, what number is it?
So like this then?
Probably just 2 plus 4.
Okay. Is it B over what?
The last one for the top is whatever.
Is it that?
Is it x?
Why? I don't give her the x.
Probably, I feel, okay, my issue is you always
Is it
say
S?
something
That
like,
was this one.
and then I have to go back and I'm like figure out.
Yeah,
where-
yeah. Is it x is greater than or equal to negative?
See what?
Actually, equal to.
Or what is it?
Alright, I
Greater
think that was about a minute, right?
Oh, wait, wait,
The first 3 of them.
This one is equal to 0.
No, like,
Hey.
why did
What's up?
I don't give her the x.
What x? In the previous
The
problems?
problem above, it says like, why, where does the x go?
You mean like,
It's 5x, where does that x go?
well, we replace x with this, right? Just like if it was h of 3, you'd replace x with 5 times 3 plus 1, right?
Yes.
Same thing, because it's 3 out here, this is h of that, right?
Yeah.
So I'm taking this and I'm replacing x, just like I did with the 3, and I'm replacing it with this now. So the x goes away, just like you did with the 3. And this becomes what x was. Does that make more sense?
So I find first what f of x is.
You find what f of x is, and you plug whatever f of x equals in for x.
Oh.
Okay? Alright, the first 3. The first 3 should all be x's in the real number set. Negative infinity to positive infinity. K of x has a denominator, which means x cannot equal negative 2. So, x is in the real number set, cannot equal negative 2. Negative infinity to negative 2, union negative 2 to infinity for our interval notation. And then m of x. Right, guys? Hey, with that interval notation, if it can't equal something, that union should be right between that number twice. Right? We're basically skipping over that number. And the last one, I can't have a negative under my radical. So I set 2 plus x greater than or equal to 0, because that will give me all positives. And then I go negative 2. Negative 2, right? Minus 2, x is greater than or equal to negative 2. So, the real number set, greater than or equal to negative 2. My interval notation, I know I'm going from negative 2, I'm including negative 2, it can equal negative 2, so I put a bracket, and then anything greater, so it's up to infinity. Any questions on these domains? Any at all? Nothing? Nada. Alright. Find the composition and the domain of the result. See, this is like what I was talking about, guys. I prefer it written the other way. If you like it written M of G of X, that's fine. If you like it written like this, that's cool. But I'm going to change this. And I'm going to change it to what we were using. I'm going to go M of G of X. Right? I'm going to rewrite it. Sweet. Thank you, Brian. So, the left one is on the outside. Then G. Right? We're working inside out here. So, I'm going to take G of X. G of X equals 4X. So I'm going to take G of X and I'm going to plug it into that M function wherever I see an X. So instead of 2 plus X, now it's going to be the square root of 2 plus 4X. That's as simplified as it's going to get. Right? We're not going to deal with that anymore. Now, in reference to domain, if I look back at those original functions, M and G, right? If I go up here, M and G, do I have any restrictions from those original functions? Yeah, I do, Colton. Which one is it? Which one?
X can't equal -2. Or the radical.
Is it can't equal or is it greater than or equal to, right? So, X is greater than or equal to -2. That's a restriction. So I'm going to put it over here for now. Because I know this radical here is going to give me another restriction. So I'm going to figure out 2 plus 4x greater than or equal to 0. I can't have a negative under that radical, so I'm going to set it greater than or equal to 0. Minus 2. 4x greater than or equal to -2, and then divide by 4. X is greater than or equal to -1/2. So that's my other restriction for this problem. Right? I looked at my start, M and G, I had X is greater than or equal to -2. And I looked at my end result. I got X is greater than or equal to -1/2.
Jasmine Moon, please report to the main office.
Now, those kind of contradict each other a little bit, don't they? One says it's greater than or equal to -2. The other says it's greater than or equal to -1/2. Now, we need to figure out which one of those satisfies both of them at all times. The easiest way that I can picture it and that I can show you is to draw a number line. Right? If I draw a number line over here, -2, -1, 0, 1, 2. All I'm going to do is I'm going to graph both of these two things. Both those restrictions. Right? We've done this before. First one I'm going to do in blue is X is greater than or equal to -2. -2 greater than or equal. Okay? Second one, I'm going to do in purple. Greater than or equal to -1/2. Oh, those are two bad colors to pick. Blue and purple. Right? Which of those two, which color, blue or purple, covers both of them at all times? The purple one does. Right? If you look on the blue, if I pick a number over here, does that cover the purple?
Oh, both.
It needs to satisfy them both at all times. So if I pick -1, that satisfies the blue, but it doesn't satisfy the purple. Does that make sense? Yes? No? So what we're going to do is instead of picking the blue restriction, this is going to be the restriction that I use. Because it satisfies both of my restrictions at all times, no matter what X value I choose. Alright, if I choose the blue one, there's X values that won't satisfy the purple one. Alright, so it needs to satisfy both. So it's going to be the purple one. So I write my domain. X is in the real number set. X is greater than or equal to -1/2. I get bracket -1/2 to infinity. Okay? Do we get that? Yes. Do we have any questions on that? All right. We're going to skip the next two. I want to go to these three. These are probably the last three we're going to do today. Now, they're different. right? Look at them, they're different. Why are they different? Well, the first one's got a 0. Second one's got what? A 2. Third one's got a 7. They have numbers, right? Anytime we're going to do numbers, anytime you put numbers into these functions, you will get a a real number answer. All right? Now, because of that, we're not going to look for domains for problems like this. Why wouldn't we look for a domain? Because what? There wouldn't be one. Why? What does the domain tell us? Restrictions on what x can be, right? Well, this is telling me x is 0. It's telling me x is 2. It's telling me x is 7. So I don't have any restrictions. I don't have a domain because x is that number. So all I'm going to do now, work inside out. We've done things like this before, right? Work inside out. If I wrote g of 0, could you do that?
Yeah.
Yeah, what would you do?
Substitute 0 in for x.
Substitute 0 in for x in that g function. So, 4 times 0 is 0. Well, now that I know g of 0 equals 0, can I plug it in for g of 0 in here? Right? I know that inside part right there. I just figured it out, equals 0. So now I'm going to make it f of 0. Right? We said right here equals 0. So I'm plugging it in. F of 0. Plug it in for x. 2 times 0 squared minus 3. Well, that equals 0 minus 3, which is negative 3. And that's my answer. Right? I got now f of 0, which is negative 3. Anytime you plug numbers in, you should get a number answer. Same thing here. I'm going to rewrite it. G of 2. So first thing I'm going to do is g of 2, that inside piece. Working inside out. G of 2. Plug 2 in for x in our g function. 4 times 2 is 8. So what I'm going to do, take 8, because it equals g of 2, I'm replacing that with 8. G of 8. Then I plug 8 in to my g function. 4 times 8 is 32. And that's my answer. Does that make sense? Yes? No? Okay. I'm not going to do the last one. I'm going to have the homework here. If you want extra practice on this stuff, guys, like we said, we skipped a couple problems today. We skipped some problems yesterday. Go back and do them and check the notes on Schoology. Right? They're on there. They tell you the answer.